to introduce the keynote speaker of today, Bruce McCarl. Uh, Bruce is a professor in Texas A&M. He got his undergraduate degree in business from Colorado, and then he got a PhD in management from Penn State. And he had an incredible career working on various issues of production economics, programming, climate change. I think that Bruce, in my view, is one of the biggest unsung hero of economics. His work allow us to both to develop methods and quantify the impact of policies on natural resource management across the board. His work on climate change is really unparalleled. I think he gave in the IPCC a lot of the calculation and the analysis of the impact of climate change on land, forest, and other areas. He developed a programming method that allow you to predict the future as well as possible. We cannot do it perfectly, but I think he did it as good as anyone. And he explained the range of issues that we study as economists. He's also a wonderful person. So I think it's really a pleasure that, and it's very important that he come here and present some of his work.
Just using. Okay. David is in a one-year visit to Texas A&M, and he said I should come here, but I had no idea what the meeting was about. So I'm going to talk some about climate change and supply chains, and I guess it's best if I look over there than here. And also some research direction stuff we've been doing. And it's not going to be math programming, which I'm better known for, but I really want to talk about some climate change issues that I think are going to have a big effect on the future bioeconomy. So it seems to be working, isn't it? Okay, now, in doing this, I want to review a little bit of the data on climate change. And I must admit, I'm fairly US centric, so I'm going to review US data largely. And what is projected, and sorry to say, but the Paris Accord isn't going to save us, or Paris Agreement. And then some findings on ag and supply chains, some mapping and econometric stuff, some limited mapping, and then some implications for research. So first, let's talk about what might drive changes in climate, in supply chains and agricultural production. So this is the temperature history from NOAA. This is a global set of numbers. You can see here that up toward the very end of the time period, we haven't been extremely warm. There's a reason for that I'll cover in just a second, but we were, I think, what is that? The 6th warmest year in 143 years of temperature history. And all of the 9 warmest years we've ever seen are in the last 9 years. So clearly there's something going on in the climate that the data seem to show. Now, this year, just in the last couple days, they say we've experienced the hottest few days in any record that we have. And I saw a statement saying it was the hottest few days in the last 100,000. Well, it turns out there's a major factor in how hot things are, and that's the state of the ocean in terms of what we call the ENSO cycle, the El Nino Southern Oscillation. That's what the EL and SO means. And this year is a La Nina year, the La Nina years are typically warmer than normal. If you look up there, the red things in here, those are the La Nina years, and the blue are the El Nino years. Down here is the climate record, and I kind of stretched it so it matched. And you can see that the hottest years that we ever had were these El Nino years, and this is going to be an El Nino year. I was saying a year ago or last November, when they said this will be a La Nina year that will probably set an all-time heat record. I looked the other day, right now we're in third place for the January to, I think it was May, temperature observations, but they're just saying that the La Nina is coming on stronger. So this may be the hottest year we've ever seen. Who knows? We're also having an effect on disasters. There was talk about turns for COVID-19 and things like that. Well, in the United States, this is a graph of the $100 billion disasters that we've seen happen and what was the cause of them. And these are all climate related. So you can see this little legend up here where this green one is severe storms, like keep my airplane from getting here 2 days ago. But tropical cyclones, and you can see a number of things. And the big thing you can see in this is that we're just seeing more and more of these extremes as we go on. And that's not only disrupting or causing money, but it's disrupting agriculture, it's disrupting forests, et cetera. Right at the moment, we have a big event with fires in Canada that's causing a lot of the East Coast to be quite smoky. And even I spent the summer in Colorado when I first got there a few weeks ago. It was smoky from those fires. This is also having a major effect in regions on water availability. There's a place called the Edwards Aquifer that's a little west of San Antonio, Texas. And this is the amount of water recharging that aquifer. And you can see it sort of exhibited an upward trend until around 1980. And then we've had a downward trend since then. This will be important in that region over time. We've also seen more land going under severe droughts. You can see here that up until about 1980, we had maybe 2% of the land under severe drought. We've had a little increase here. This one, I think, is extreme drought, and this one here is severe. We've had a bit of a jump up in the incidence of severe drought since then. So again, something that's going on in agriculture. Madhu told me Illinois is having a drought right at the moment. And if that persists much longer, that's probably going to have a big effect on corn production in the Midwest. Is Indiana and Ohio having it too? Or Texas is, but I'm not there at the moment. So here's one that David told me something yesterday that I'm afraid I'm not so sure I agree with, which is we were trying to study what's been happening to corn yields over time. And if you take a 1950 to 20, I think we went up to 2022 with this, you get a yield increase of about 2 bushels per year. And that's a number they used to use at USDA, saying that's what we're going to depend on. If you take a regression from 1950 to 1973, you get about 2.6 bushels per year. So that was a substantially hotter period or greater growth period. If you go from 75 to 2011, you go a little bit under 2 bushels a year. If you go from 2013 to 2022, we're under 1 bushel a year. So we're definitely seeing a slowdown in yield growth rates. And that's going to indicate whether or not we can keep making corn ethanol or things like that if we continue things like this. So that's just a few things. I could go on for an hour about different climate change effects, but let's talk a little bit about what's projected. Now, this is from the 2014 IPCC report, and the black lines are what they observed, and then the different colors are under different amounts of greenhouse gas abatement. This one here is the business as usual without a great deal of greenhouse gas abatement, where they see about a 5.5 degree warming by the end of the century. This is what happens if all the current agreements to the Paris Agreement are in fact implemented. It's still a little bit above 4 degrees of warming. This one here is a fairly extreme climate mitigation scenario, and these last two are from Disneyland, I think. They indicate that we immediately cease all emissions. You can see that this makes a big difference by the end of the century, but it makes hardly any difference between now and 2040. So basically, between now and 2040, 2050, we expect about as much warming as we've seen in the last 100 years. So this is a huge challenge to me for agriculture. How do we maintain our productivity in the face of that kind of a change? So our action possibilities, well, we can sit back and take what our President George Bush said around the Kyoto Accord time, which is, we don't have enough information on climate change. We're going to continue to wait for what happens. We can reduce drivers, meaning that we can control greenhouse gases or put reflective aerosols up in the atmosphere and otherwise stop the accumulation of heat at the surface level. And then we can do adaptation. And to me, the reduced drivers, that refers to those different colored lines I just went through, but that's going to have delayed response. It's going to be 25 years before we feel much of that. So adaptation is probably where agriculture needs to be over the next 25 years. So what can research developments and technology and things like that do to improve our yield future? So that kind of sets the stage. Now let's take a look at ag productivity, land use, and infrastructure. Well, when we were looking at this a while back, we were looking at how land is being used between crop and grassland geographically across the US. And I want to go through some of that data. The first thing we wanted to look at is how land is allocated between pasture land and cropland and other land. And you can see here, across the bottom, this is an increasing average temperature. Up at the top, this is the cropland share, this is the pasture land share, and this one down here is other land uses. You can see when we pass some critical inflection point, which is 48 degrees or so average annual temperature in Fahrenheit, that the cropland share stops to drop. You drive west from College Station, Texas, where Texas A&M is, out to El Paso, it gets substantially warmer, it gets substantially drier, and you don't see crops. You can go 800 miles and not see very many crops in that area. Also, when it gets hotter, we see decreases in livestock stocking rates. That 800 miles of land has livestock on it. At first, you see a bunch, but then as you get further and further away, you need the binoculars to see the animals because they're scattered all over everywhere. We also tried to take a look at what happened to corn, where corn was being produced in the US. And in 1975, this is the distribution of counties that had a significant amount of corn in it. The color reflects a bit of the density. So you can see is light colors. The corn wasn't real dense. Up in here is where the denser corn production is. Notice between 75 and 2020, this stuff disappeared. It's just about gone. There's a little bit of green in there. The Corn Belt moved kind of north, and it moved significantly west out here. This move into Nebraska and Kansas is moving into the Ogallala Aquifer, which is a depletable aquifer, which is not necessarily a good long-term solution. This move up north here is a substantial move into the Dakotas and other places. And I've been trying to get Canadian data, but Canada produces now about 6 times as much soybeans as it did back then. And I think it's like 3 times as much corn. So not only is this movement happening in the US map, but it also would be happening here in Ontario and some up in Manitoba and Saskatchewan. So we started talking about what's taken the place of this corn. And initially, I thought it was going to be sorghum and cotton. And we did some work on that. But then lately, we started graphing what we call other hay, which is these operations where land's in grass, and they go in and they cut these large round bales and then use it for cattle. And you can see here that there was basically no reported other hay in this area back in the 70s. And now there's quite a bit in some of these areas. And here it's more dense here. There was a bunch of it up here in the far north, but it's been displaced some by corn and soybeans. And I'm not showing you, we have graphs for 18 different commodities on this. Corn's one of the more dramatic ones, but so are soybeans. When we take a look at this corn movement and what happened to wheat, here you can see that the wheat has moved north and is being displaced. So we're pushing stuff up into Canada. And there's a limit to how much of that we can do, because there's something called the Canadian Shield, where the soil is quite shallow and there's rock up there in the northern parts of Saskatchewan and Manitoba. Cattle also are exhibiting this. This is where Brahman cattle were, and here's where Angus cattle were. We couldn't really get data on the incidence of breeds, but we got the breeding association memberships. So this is showing where people belong to those breeding clubs in the different areas. And you can see Brahman, which is a lighter colored white animal, sometimes smaller frame, a big bump on the back. It's from India, a little bit more designed to handle heat than are the darker colored Angus animals. So now let's talk a little bit about productivity. Schlenker and Roberts got a lot of press. I don't know how many have seen that, for showing that when temperatures got hot, that yields dropped way off. Well, basically, if I take somebody's plant and I put it in the freezer, it's going to die. If I put it in a blast furnace, it's going to die. So in between, we kind of should expect this inverted U-shaped curve where there's some optimum set of conditions for growing crops. And when you go above it, you're going to start having them drop off. David did some work a long time ago about adaptation. What's happening is that other hay, if I had a graph of its yield, can accommodate hotter temperatures, something like corn cannot. So as that temperature gets warmer, it's natural to see a shift out of one crop and into another. So this is results that were in Schlenker and Roberts. A student of mine spent a year and a half doing some fancy econometrics to find their exact results that they found. And anyhow, you can see that as the temperature gets somewhere above about 30 degrees centigrade, that the yields greatly drop off. And that means areas like Texas are probably not going to be able to grow much corn for much longer. But that's not the only game in town. Carbon dioxide is also an important factor. And we tried to take a look at decomposing the carbon dioxide effect from the technological progress effect. the guy running our experiment station hated our results because we said 40% of the yield gain in cotton is due to more carbon dioxide. So if we manage to mitigate the carbon dioxide, we're going to lose that. Same's true on rice. The other crops aren't so much affected, wheat a little bit. Beyond that, we tried to take a look at productivity on cattle. And this is the relationship between 4 different measures of cattle productivity. The red one is cattle slaughter weight at feedlots. The grayish one here is milk production. The blue one here is the cattle birth rate, and the green one is the calf survival rate. Notice in all those cases, we have that same inverted U-shaped productivity. And this means that the cattle herds are moving as well in order to get into these better areas and get out of the areas where it's too hot for the production. Another student of mine looked at hog slaughter weight and broiler slaughter weight, and that's these pictures down in here. Again, the same kind of U-shape. We did try to take a look at what would happen as the climate evolves to yields. And you can see here, this one's from milk, and we have increases in most of the major milk producing areas, which are in the north, although there's a lot of milk now being produced in this Great Plains, and most of that has negative impacts. Calf survival rate, no surprise, when you get rid of some of those real cold conditions up in the north, you're going to get benefits. Down here, you'd have losses. This one's slaughter weights, again, the same sort of thing, but this implies we'll probably see movements in our feedlot industry as to where it's located. And calf birth rates, same sort of thing, although this may have some negative consequences because a lot of the calves are grown in this area and then fed out here. So some negative consequences there. Okay, the final thing I'll just talk about, I'm not going to read all that, is grassland productivity. We're not only having an effect on crops, but we're also having an effect on the species mix on these large grazing areas and the nutrition of that and water availability. CO2 also has an effect there. So just a little bit now on supporting infrastructure. David likes to talk about, likes to talk about supply chains. Well, we tried to take a look at where grain elevators were. When I went to Purdue in 1973, 50 years ago, there were grain elevators, 2 of them within a couple miles of my house. They're all gone now. There's been huge consolidation in that industry. And as a consequence, we see many more of these great big ones that are designed to take care of economies of scale in supply shipping. So they're sitting on barge areas on the Mississippi River, or sitting on areas where they have a railroad track right below them and they can load what we call a unit train. So we were trying to take a look at what happened to the incidence of grain elevators. And this is employment in the elevators. And you can see a northward shift in employment. So we've gone from the little ones with a few employees to the bigger ones with larger employees. This is the number of establishments. And here you can't see so much. I mean, here there is a bit of a northward shift here over time. I could show it on my hand, maybe. Okay. We also tried to take a look at, under these different climate change scenarios, what a model would say. So this is my U.S. National Agricultural Sector model, and this is the base case. You can see in most of these cases, we get a northward shift and a little bit of a westward shift in the incidence of something like corn. and it moves out of some of these areas over here. Here, the green is where there's corn surplus more than locally used. The red is where there's a deficit. And we thought this would have big implications for the supply chain. What it does is it reduces the amount going down the Mississippi River to New Orleans and Baton Rouge, and it increases the amount going out by train to the Pacific Northwest and the East Coast. So again, this is shifting where productivity is, and then it's shifting what the supply chain is doing. Similar thing with changes in barge shipments as opposed to changes in rail shipments. So in the US, as you're moving that north and west, you're moving away from these big rivers, and so you become more dependent on rail. We also looked at animal slaughtering facilities. Again, there's been a big change in their size and magnitude and operation, but you can see here that there's more in more recent time periods that are spread somewhat more up in here in the north as opposed to what there were 20 years ago. So that's kind of the climate change story, and I don't know how I'm doing on time. But let's talk a bit about research. Now, climate change, I've just shown you some of the stuff about how it's affecting yields, reducing the rate of yield increases, altering water supplies, altering crop water demands, pest incidents, stimulating shifts in crop mix for adaptations and requiring some new infrastructure. I think it's diminishing yield growth rates and expanding the needs for more research efforts. So we need more breeding and that sort of thing, but that's not what's happening. Now, before I show you the graph of what is happening, let me talk a little bit about the treadmill. Willard Cochran talked a lot about the technological treadmill and how some farmer could not help but adopt new technology. I think there's a climate change treadmill that's a new one, which is if you're sitting in central Illinois and you're happy with your productivity, then the climate's is starting to change on you some. You're either going to maybe discontinue one crop and take on another one, or you're going to invest in drought-resistant varieties and things like that to increase your productivity there. So no longer can we do research where we do something and we say, we've got that problem good for this area. We now have to do some maintenance research in that area to keep the productivity up higher. So today, climate change is really introducing two new research needs that we didn't see before. One of them is this research need in adaptation. We're going to try to develop new varieties people can adopt to maintain the productivity at a place. I just responded today to 2 RFPs from USDA for more work on carbon sequestration. We're doing a whole bunch more work now on bioenergy, on carbon sequestration, things like that to mitigate climate change. So no longer when we're doing ag productivity research or ag production research, are we doing research on productivity enhancement? We may also do work on adaptation or productivity maintenance and on greenhouse gas matters. We tried to take a look at using something called CRIS data, Current Research Information Service, I believe is what that stands for. It's the way USDA says we spend our money. And so here's USDA. This is how much money USDA says we spent on soil research from 1993 to 2016. Here's the amount spent on animal research. This is the amount spent on crop research. This is the amount spent on other research. If we total these three and just look at productivity related research in terms of a percentage share, notice that it's been diminishing. It started at about 65% or about 2/3 of the USDA investment, and now it's down to about 56%. So at the same time this climate change threat is coming on, we're spending much more money on this other category, which is things like bioenergy, maybe consumer preferences, some environmental matters, and a bunch of other things like that. So we are not increasing our productivity investment. Also, if we take a look at crop adaptation, then we look over time, up until the 1990s, we weren't spending all so much. That may have been like pesticide research as the pesticides become limited in availability. And then we started with a bunch of crop adaptation research, and that's been growing. We weren't able to find something for mitigation research on how much is being spent on carbon sequestration and things like that, but I'm sure that share is growing because there's a new proposal called once a week in the US, it seems, for various kinds of mitigation work. The other thing is I want to look a little more at the challenge. I should have had this earlier. This is corn yields this is the corn yields nationally, but this is corn in the Corn Belt, and here is corn in the Southern Plains. And you can see again that the rate of technological improvement was faster up until about 1980, and then we hit some kind of a break point and it's been slower. And we looked at 18 crops in 13 different regions, and they all look like this, except cotton, which carbon dioxide is playing in on. So we tried to do some econometrics on this data. We tried to do an econometric model that had the current yield as a function of research and development investments. And then one of these terms is a climate change investment, or a climate change thing. W is climate change variables, and I is some other input usage. In doing this, we ended up having to use a trapezoid. Wally Huffman and Julian Alston and them use some kind of a trapezoidal pattern. Unfortunately, this eats degrees of freedom like crazy. So we wanted to go back 30 some years, but initially we only went back 17 years with this trapezoidal pattern. So a research investment in year 0 would have the following implications for the next 20 years. No returns for a few years, and then an increasing and decreasing pattern. We ended up estimating that model, and when we estimated it using data from USDA on research investments, and the time period that we had the ag R&D data for, come on, there we go. We ended up finding significant increases in these crop yields due to research and development investments. And we really couldn't isolate that down to corn, so we had total research and development investment. But we also saw negative effects out of climate change. So what I conclude from this is that climate change is one of the forces that's causing this diminishing returns to technological investment and diminishing yields. We're going back with this and doing it more spatially, but it's taken some time to get all the data together and get the attention of somebody to do some of the estimation work. So what we did try to do is do a partitioning to try to find out how much more research development investment would we need in order to compensate for the climate change effects. And the table is here. Basically, to get back to pre-1970 levels, we find between a 7 and as much as a 60% increase in research and development funding is needed to get back to the the productivity increases we had historically. So anyhow, I do think there's a big research agenda here in the climate change adaptation work, and we're going to need to spend substantially more money to achieve that. So with that, I was trying for 45 minutes. Looks like I'll hit it. Climate change not only directly affects productivity, but it also is affecting the effectiveness of ag research and development. Most of the climate change studies I'm aware of that tried to take a look at what climate change has done to productivity really say, well, the yield's going to go down. I think they're wrong. What they're saying is they also probably have a time variable in there for technological progress, and it keeps pushing the yield up. The question is, it's bending that productivity growth down. Whether we'll get to the point that it actually is a purely negative effect and completely overcomes the effect of research and development investment, I'm not sure. But there are yield and pest effects. There's going to be a lot of changing locations of where these crops are grown, meaning we need to spend more money on localization research and more on dissemination results. We do need a big maintenance R&D investment potentially. We need to also to do research on ag mitigation. You know, what can you do with cover crops in order to greatly increase carbon and reduce nitrous oxide emissions? And then we may well need to increase R&D and try to increase the share going to productivity to compensate or otherwise increase that productivity. So that's it. Thank you. I was going to give her one of the microphones.
Yeah, thanks, Carl. My name is Keith Fugley from USDA.
And the source of our new and improved data.
Well, I was just wondering if you could talk about that and what do you think might be the role of the private sector in and GM investments in adaptation? Yeah,
I'm probably going to screw this up, but I think Keith and some others have been showing that the private investment is becoming more and more important and more prominent over time. And so what we're trying to do in this data is have both public investment and private investment. We can get public investment on a regional basis. The private investment has pretty much been just national. I think Keith told us use a number like 5% of their gross returns and try to allocate it out that way. But clearly it's an important factor. Monsanto invited me, I never knew why, to go to their St. Louis facility and listen to their corn breeding. And they were spending, this was 5 or 6 years ago, an awful lot of time on drought resistance. And I guess, I don't know who did the triple stack, but they were probably one of those who was in the middle of that. We not only need to increase the public investment share, but we need the private investment share. And that where I show there's a dilution of the private of the investment share, that's really only public. And I don't think many of the private people are investing anywhere near as much in any of those non-productivity type of things. So it's a crucial thing. We're trying to get a hold of it, but it's difficult to get the data to get a hold of that. I imagine trying to get a 35-year history in private investment. Keith has done a wonderful job getting some numbers together on that, but how reliable they are when you get back there 30 years, I think is a little hard to judge.
I may take my privilege. One thing about this consortium is that we have been working on the issue of biotechnology and bioenergy. And the biggest issue that we found is the issue of regulation. Do you have any assessment about the impact of regulation? At least in our perspective, I think, is that you have more regulation, there is less private investment, and also less public investment because there is a complementarity, public investment, private. So how do you think about the role of regulation? The other thing is is there any way to try to assess the impact of regulation on productivity by preventing the use of modern biotechnology?
You're the one that should answer that stuff.
Well, no. This is really, no, I know, but this is really important because part of the debate.
Well, I do know, there's a lot of talk in the productivity arena that we haven't invested so much in other hay productivity or switchgrass productivity. And to the extent that regulations push us to have to produce that stuff, then we should be able to make pretty rapid technological progress. Corn may be one that I've been hearing the Club of Rome, remember that from way back years ago, that we're really exhausting the possible productivity increases in some of these conventional crops and having to do more and more extreme things. So to the extent that the regulation forces us into the biofuel business, then I believe that there's going to be some large investments and large productivity on that side. On the other hand, I used to be on a national panel about bioenergy policy at DOE, and the guy from General Motors was absolutely furious at EPA because they spent $1 billion developing a flex fuel vehicle, and then EPA abandoned the renewable fuel standard that today we're supposed to be producing twice as much renewable fuel as we are now, but we don't have really the cars and gas pumps to do it. And EPA isn't pushing that, although just recently they started increasing the cellulosic requirements again, like a week ago. So I think the regulation is in part guiding where our research investments are spent. They also, through crop insurance and things like that, may be biasing where the research investments are being spent. But beyond that, you can answer the rest of your question.
Bruce, that was really interesting. Stuart Smythe from the University of Saskatchewan, and you're right. We see far more corn, soy. I've never seen as much corn growing in southern Saskatchewan as I have in the last few years, and soybean yields are comparable with Minnesota yields. My question is, do you have a sense as to how does the American Farm Bill and the subsidies skew some of the crop production economics? Do you think that has an impact in what you're showing?
Well, a lot of people say the Farm Bill subsidies, but today we really don't have Farm Bill subsidies. We have insurance subsidies. Our farm support has almost gone all over to the insurance side. And what I don't know if Keith ought to talk about this, because he may not completely believe what I just finished saying. But today, the insurance subsidies are allowing riskier crops to be grown in certain areas because, we've cut some of that tail off. And that may have dampened some of this adaptation. It may have slowed down some of that northward and westward movement that we're seeing in the cropping. I think the bioenergy has something to do with it for sure, because before we started into the renewable fuel standard, corn prices were about $2 a bushel. Now they're about $4 a bushel, and they seem to just be staying up there. I thought they were going to start sliding back down due to technological progress, but that really hasn't happened so far, perhaps because of COVID in Ukraine and a few other things. What I want to know from a Canadian is why the heck can't I find national data on crop acreage across your country? Every darn region defines counties and municipalities and something else, and the federal government doesn't publish it. I have to beg somebody in each of the regions to tell me where to get the data. And so far, I haven't been successful with that. I had a guy from Ag Canada email me yesterday, and I said, please, do you have some of that data? He wanted me to help him with a GAMS problem, so I'm going to try to trade.
Travis Reynolds, University of Vermont. So many of the maps you just showed have that really stark north-south divide within the US. And it's kind of a microcosm of the planet where there are real winners and real losers under these climate change scenarios. So when you talk about more public research being needed, do you think in the US there is political will for federal funding to do things that help southern states, whereas the northern states might be better off? Well, bring on the agriculture, bring on the livestock, bring on the processing infrastructure. We'd love to have it up here. Do you see that being resolved?
We'll wait till the Republicans come in, because then the southern states may get more favorable treatment than the northern states. Who knows? I'm not sure we have the political will to increase R&D funding. The total amount of R&D funding, certainly on the public side, has been going down, right, Keith? When you add in the private side, has the total been going down, or is it fairly level? Fairly level. So there's been a shift, public-private partnership. There's been some shift over there to public, with us facing more environmental calls and things like that for some of the public investment. I mean, that other category there is environmental and consumer, and we're certainly seeing more of that. But it's not only a north shift. The fascinating thing I found is it's north and west. When you go west, you go higher. And when you go north, you go colder. So in both of those, it's that kind of direction. We did a study one time in Oregon, and everything was going north and east. Well, up to the Cascades and up further north. So Vermont, if we did a study on the East Coast where agriculture is pretty insignificant, sorry to say, there we would find probably north and eastward movements in some of the cropping commodities. But I really think this is a big challenge for design of the supply chains and research investments. Oh. Sorry, she was only a foot away.
Yeah, this is Regina Berner from the University of Hohenheim in Germany. Thank you for this really interesting presentation. I would be interested, you showed this interesting diagram that productivity-focused research is declining. Could you explain how methodologically you decide what is that? Because if I look, for example, a lot of research that's done in German universities looks at how can we maintain productivity while at the same time addressing, for example, biodiversity concerns. So they look at, this research looks at productivity and environment in the same project. So how do you differentiate what is exactly productivity and what is something else?
Well, I must admit that when I fill out these forms, I'm not sure how accurate the portrayal is of what I've just filled out, but this CRIS system is Current Research Information System, is that right? And in the CRIS system, every year, if you're supported by federal funds, you fill in an allocation form and you allocate your effort to a number of different categories. And I can't remember exactly what the categories are, and it's been a couple years since I looked at this, but productivity enhancement and the commodities and things like that. So This is out of our annual reporting where we fill this form in once a year telling how our money is spent. I don't quite, do you do the same thing at USDA on projects? Do you report different categories? So it's a very crude instrument, but on the other hand, you certainly can differentiate productivity from consumer studies or some pure environmental studies. So I'm sure we swept a bunch of biodiversity type research into that, where they were doing productivity and biodiversity at the same time.
My question's kind of similar to Travis's. You mentioned the increased need for R&D over the next century. However, there is an unequal distribution of that funding worldwide, which is going to create competition. How do you address this and the social inequalities this brings out, which are the same social inequalities that are exacerbated by climate change?
You have more faith in the political system inherent in that than I do. We just eliminated in the United States, the Supreme Court eliminated diversity in college applications, and Texas banned the DEI, diversity, excellence and inclusion. I don't know what the E stands for. Equity, diversity, equity. They banned universities from having even such an office. So in Texas, I kind of doubt if we're going to do very much in terms of helping disadvantaged groups in terms of research productivity. Now, you know, there's a couple of different ways of looking at this. I think the statistics, Keith or David may know this, that about 80 to 90% of our productivity is out of the 10% largest farms or something like that. So if we're really talking a productivity issue, the diversity issue is not necessarily right in the middle of that productivity issue, although it really poses an information dissemination issue. How can we get that large land block to be more productive to help address this question? There's very much large issues in the lower Rio Grande Valley. You know, there are a lot of large farms, but a lot of the small production is off of land that's water that's saline supplies and not very productive and very low productive labor and that sort of thing. USDA is and NSF are increasingly putting diversity criteria into their funding evaluations. So maybe we can do a little bit better from that perspective, but I'm not all that hopeful. I have a feeling, you know, we'll probably still spend most of the money in Illinois and give it all to Madu or something like that in those high productive areas. And in the upper high plains of Texas, you know, up around the Amarillo and the Ogallala Aquifer, very productive system. Around College Station, not so much. And we do spend research investment money around there, but not really on the more traditional systems.
Thanks, Bruce, and thanks for the plug for giving me more money. I was just wondering, when you're looking at these shifts due to climate change across regions, you know, how are you considering potential for changes in irrigation use and other fertilizer use and so on to make up for the climate impact and offset some of that negative impact?
Well, we have some data on irrigation incidents, and we've put that into these models. And we are, when we're doing the individual crop models, we haven't done the R&D investment on this, but we have individual models for dry land and irrigated production, and the irrigated production in most cases is much less sensitive than the dry land production. There's no real time series that I can put my finger on. Maybe you know where it is on fertilizer use. I mean, it's hard to even get a cross section, much less get a time series. It usually comes from models. And I'd really like a time series on irrigation water use, because I think climate change is dramatically increasing that. But again, we don't have, I don't know where to get that data from. Maybe the Illinois detailed surveys and the Kansas detailed surveys would have that. But I don't know if they've got enough of a panel in there to look at that. But what we're really doing now is we're trying to observe what is happening. And I showed you the soybean curves, but if I showed you all the wheat curves, and I showed you corn, if I showed you all the wheat and all the soybeans, alfalfa, they're all showing some of these kinds of shifts. Cotton and sorghum kind of go in circles. They're pretty much taking over in some of the South. So you get rid of the corn and maybe you put sorghum and some cotton on there. But this other hay thing really surprised me. Other hay, and if you group other hay and pasture together, we're really seeing it take over in more of the southern areas of the country, and the grain crops are moving further north. We did find about half of that northward movement in econometrics could be explained by climate, meaning about 50% is coming from crop breeding and other kinds of things, and about 50% as a climate reaction.